All right. So hello. Let's look at this question. So we have integrate the following trigonometric integral using u-sub and trigonometric identities. So most of the time we're going to have to use u-substitution and trig identities to do this. So let's go ahead and get started. So here we have the integral of sine to the 6x cosine to the 5x dx. Now, the one thing we need to do is try to get it so that either there's a sine left over or a cosine left over in terms of du when we do u substitution. So let's see here. If I were to go ahead and take out a cosine, right? So let's go ahead and do that. So the sine to the 6x is going to be the same. And then we're going to have cosine to the 4th x because we're stripping out a cosine, and then times cosine x dx. So notice that this part is the same as this stuff, okay? And now, let me write that a little better. And now, if you look at this, we know that cosine to the 4th x, if you kind of use your laws of exponents, you can see that it's cosine squared x squared. So cosine squared of x and then all squared. So we can say, and we know that by the Pythagorean identity, cosine squared x is 1 minus sine squared x. So we should know this from trigonometry, right? So we have this is going to equal to 1 minus sine squared x and then all squared. So let's go ahead and just kind of simplify this. So in other words, this part we're going to put as 1 minus sine squared x and then all squared. So we have the integral of sine to the 6x times 1 minus sine squared x all squared. So again, just labeling here. I am very visual, so I like to color code a lot. So now, and then times cosine x dx. So now, I'm sorry, hold on. There we go. So now, notice that we have a u and we have a du. So this can be my du, and then my u can be sine x. So then du is cosine x dx. So now we can see that we can clean this up. So we have the integral, and we want to make it in terms of u. That's why most of the time we're going to have to use u substitution here. So we have u to the 6 times 1 minus u squared and then all squared. So now here's the thing, okay, and then du. So now here's the thing. We're gonna have to simplify this, okay? So we have the integral of u to the 6 times, and it's gonna go. And the reason why I'm keeping it in color code is because it's just to kind of know at the very end that u is gonna be sine x. So we're going to use that formula a minus b squared equals a squared minus 2ab plus b squared. If you don't like doing that, you can also simplify by FOIL method. So you will, in this case, we're going to get 1 squared minus 2u squared plus u to the 4th, right? So again, let's just go ahead And again, just color code here. Now let's go ahead and simplify this, and it's du, right? So let's just take off the, the color coding for du. So we're just gonna simplify a little more. So u to the 6 times 1 minus 2u squared plus u to the 4th, and then du. So then we can now go ahead and distribute. Okay, so we're going to distribute this. So we get u to the 6, so integral of u to the 6 power minus 2u to the 8th, right, plus u to the 10th. Okay, so and then du. So now let's go ahead and integrate by power rule. So the integral, I just want to say, of u to the n du is u to the n plus 1 over n plus 1 such that n does not equal -1. Okay, so this is the power rule of integration. I know I'm writing a lot, but we want to make sure we understand these formulas. The thing with calculus is that it's a lot of it builds up. So I'm just stating as much as I can to kind of refresh our memory. So then we're going to do that. We're going to do u to the 7th. So obviously you just add 1 and then make it over the 6 plus 1. So u to the 7th over 7 minus 2 u to the 9th over 9. Okay. And then plus u to the 11th over 11. So again, I'm just adding 1 and then making it to that same power. So now, and then plus constant integration c. Now we're going to substitute u back in. U equals sine x back in. So thus the integral, and we're gonna just put our final answer in here, of sine to the 6x cosine to the 5th x dx equals u to the 7th. I'm sorry, equals sine. It's going to be sine to the 7th x over 7 minus 2 sine to the 9th x over 9 plus sine to the 11th x all over 11. And we must not forget to add our constant integration c. So this is our final answer to this problem. So yeah, it's a pretty lengthy, integration is a pretty lengthy topic, but that is how we do this. So I hope this helps, and yeah, thank you for watching.